Hello everyone, welcome to Engineering Classes YouTube channel for a second video lecture series in control systems. In the previous video lecture, we have understood what the control system is. In this video lecture, we shall consider the concept of classification of control systems. Control systems can be broadly classified as open loop control systems and closed loop control systems. Before we actually consider the definition of open loop control systems and closed loop control systems, what we shall do is we shall consider the real life examples and we'll try to understand the control systems out of those things. Let us consider examples of control systems. First example could be traffic control system, and then we have room heating system, and lastly we'll consider washing machine. Let us first consider the example number one, that is traffic control system. Traffic control by means of traffic signals operated on time basis constitutes an open loop control system. The sequence of control signals is based on a time slot given for each signal. Whatever the time slots are given for red, yellow and green, they are dependent on the time slots, and it is based on the traffic study. The system will not measure the actual density of the traffic before giving the actual signals. It gives the signals in a sequence as per the setting, irrespective of the actual traffic. Since the time slots do not change according to traffic density, the system is an open loop control system, mainly due to fixed time slots. Let me consider the same traffic control systems, how we can make this as closed loop control system. This open loop traffic system can be made as a closed loop system if the time slots of the signals are based on the density of the traffic. In a closed loop traffic control system, the density of traffic is measured on all sides and the information is fed to a computer. So what we do is we'll fix the sensors everywhere, and whatever the input we have, that is fed to the computer. The timings can be dynamically changed by the computer. Such a system is an closed loop control system. If we can change the time slots dynamically using the actual density of the traffic, the same open loop control system now becomes closed loop traffic control system. So this is the first example. Similarly, let me consider the second example, that is room heating system. A room heater without any temperature sensing device is an example of an open loop control system. Here we do not have any temperature sensing device. Hence this becomes open loop control system, even though there is a change in the temperature, because we don't have any measuring device that reads the temperature and gives the input to the computer, and computer dynamically do not change the temperature of the room. Hence this becomes open loop control system, an example for open loop control system. Now we shall see how the same room heating system can be made as a closed loop control system. It can be made a closed loop control system if a thermostat is provided. So what it does is a thermostat will be there. It continuously measures the temperature of the room, and it feeds the input to the computer, and computer can dynamically take the decision, and it can reduce the temperature or it can increase the temperature further. So that is an example, a room heating system. It could be open loop control system, or it can be made as a closed loop control system that we have seen now. Let me now consider another example, that is a washing machine. A washing machine without any cleanliness measuring system is an example of an open loop control system. There are three stages in there could be many stages in the washing machine. So broadly they can be classified as soaking, and then we have washing, and then we have rinsing. All these stages happen or they operate on a time basis. say for example 15 minutes is given for soaking, 20 minutes for washing, and another 15 minutes for rinsing. So these stages happen on the fixed time basis. Such a system are known as open loop control system, as they operate purely on time basis. The same example, that is washing machine, can be made as a closed loop control system. Now we'll see how it can be made as a closed loop control system with a desired cleanliness level. If the level of cleanliness can be measured and compared with the desired cleanliness or the reference input, and the difference is used to control the washing machine time of the machine, so that the same washing machine becomes a closed loop control system. Say for example, after soaking, I have a reference input that gets compared. If it is okay, then it goes to the next stage, that is washing, or else the level is not on par with the reference level, then the current stage gets repeated until and unless the output is satisfied. That we say it as controlled output. Then it goes to the washing. Again, after washing, we have a cleanliness level set. The cleanliness level now gets measured and it is compared. If it is okay, it goes to the rinsing level, or the same washing level keeps repeating. So in that way, we can make this as a closed loop control system. So these are the three examples. From this we can understand what is open loop control system and what is closed loop control system. We have already understood. Now we'll see the actual definition of open loop control system. Any physical system which does not automatically correct for variations in its output is called as an open loop control system. We have seen this in the examples of traffic control system, room heating system, as well as washing machine. The output does not automatically correct for variations. So that we have seen. This is called as open loop control system. Such a system may be represented by the block diagram. So now we shall consider the block diagram of an open loop control system. There is an output, there is an input, and there must be an output, and in between we have one block called as controller, and we have another block that we call it as plant. In these systems, the output remains constant for a constant input signal. Here, the output is dependent on the input, but input is independent of the output or any changes in its output. So this is the definition of open loop control system. So now we have to understand what are those two blocks, controller and a plant. First, let me consider the definition of plant. The portion of a system which is to be controlled or regulated is called as the plant. So this is the portion of the system that needs to be controlled or regulated. How it is controlled or regulated? Using the another block called as controller. The element of the system itself, or this could be an external to the system which controls the plant, is called as a controller. So this is the definition of plant and controller. So now we are in a position to understand the definition of closed loop control system. What is this? Any physical system which automatically corrects for variations in its output is called as closed loop control system. In the open loop, we said the system which does not automatically correct for variations. Now we are saying this system automatically corrects for variations in its output. So this we are calling it as closed loop control system. It can be achieved with the help of a feedback. So every closed loop control system will have a feedback. This is another important portion of closed loop control system, is that they are going to have the feedback. Now we shall see the block diagram representation of closed loop control system. So first there is a reference input. So previously we said it is just an input. So now we are calling this as a reference input. And then we have a block called as control elements, and then we have got a plant. So control and plant, these were present in open loop control systems, and here also they are going to be present, and we had output there. Now we are calling it as controlled output because we can change the output as per our wish. Hence it is called as controlled output. And then we have got another important block, feedback path elements. So this is the very important block of closed loop control system. So then we have error or actuating signal. So that block, cross block, is known as error detector, and the signal coming out of that is an error or actuating signal. So that is the block diagram. So now we shall see the individual blocks. The error detector compares the signal obtained through feedback element, which is a function of the output response with reference inputs. So the job of the error detector is to compare the signal obtained through the feedback with the reference input. Very simple one. And next we have any difference between these two signals constitutes an error. So the difference between the feedback and the reference input is called as error or an actuating signal which actuates the control elements. What is there in control elements? Control elements in turn alter the conditions in the plant in such a manner as to reduce the original error if there is any error.